Next, we're going to work on multi-step word problems. Remember our strategy, UPSC. UPSC. The first step is to understand the problem and ask yourself, what do you already know about the problem and what do you need to find out? Next is to plan. You want to estimate the answer, draw a picture, or look for a pattern. Next is to solve the problem. Make sure you stay organized, label your work, and go back to the understand and plan steps when needed. Lastly, we're going to check our answer, asking ourselves, does our solution answer the question? Is the solution reasonable? And does it make sense? So now I'm going to come down to problem number 23 and read over it and annotate my text. And I'm first going to do the understand strategy. So while I read it, I'm thinking about these two questions. Angelica is buying some things for her dog's birthday. She buys him a cupcake for $11. She also wants to buy him as many treats as she can, which are $3 each. Angelica has $25 to spend total. How much money will she have left after she, typo, buys the cupcake and as many treats as possible? So I'm going to go back and reread it and circle, box, and underline important information as I go. Angelica is buying some things for her dog's birthday. She buys him a cupcake for $11. So the cake is $11. She also wants to buy him as many treats as she can, which are $3 each. She has $25 total to spend. How much money will she have left over after she buys the cupcake and as many treats as possible? So I'm going to ask myself these two questions first. What do I already know about the problem? I know that Angelica is buying a cupcake and as many treats as she can, and she has $25 total to spend. And next, I want to know, what do I need to find out? So you might think that you want to know how many treats she could buy, but no. This one is asking, how much money will she have left over after she buys the cupcake and as many treats as she can? So make sure our answer is referring back to how much money she has left over. So that's very important. Next, I'm going to do the plan step. I'm going to estimate my answer, draw a picture, or look for a pattern. So I know that my answer has to be, I'm going to estimate first. It has to be less than $25 because she's spending $11 and then the things are $3 each. So it has to be less than 25, and I'm going to make that even more exact. I'm going to round 11 to 10, and I know she already spent about $10 on the cupcake. So I'm going to subtract that from the 25. So I'm going to say the answer has to be less than $15 because we're going to see how many treats she could buy, and then we're going to see how much money she has left over. So my answer must be less than $15. Next, I'm going to continue planning my problem by drawing a picture. So I estimate the answer and I'm drawing a picture. So I'm going to start off with my handy dandy tape diagram that I've been drawing. This represents the total. And I know my total that she has to spend is $25. So total equals $25. So the total is not always going to be what we're trying to find out. We know how much money she has. And I'm going to right now put in left. I'm going to add a category for how much she has left because that's going to answer my question. Equals question mark. So I always want to make sure somewhere I have a question mark that's going to answer my question. So what I'm trying to find is how much she has left over. Next, I'm going to start drawing. So she bought a cupcake for $11. So I'm going to label this part cake, and I'm going to label $11. Next, I'm going to put in one treat. So I'm going to put T for treat, and that was $3. And I'm actually going to start solving the problem with this picture, but I'm also going to show you another way that you could solve the problem over here. So I'm going to start adding these up. 11 plus 3 is 14. So far she spent $14. So I'm not at $25 yet. I didn't go over it yet. So I could continue adding treats until I get close to $25. I'm going to add another treat, which is $3. And then 14 plus 3 more is going to give me 17. All right, so now we're up to $17. I could still add some more $3 treats. So I'm going to put another treat here for $3. I'm going to add 3 and 17. Will give me $20. I could still add another treat because they're only $3 and I've only spent $20 and I still have up to $25 total. $3, that's going to give me, plus 3 more, would be $23. Let's think now. The pup treats are $3 and I spent $23 so far. Can I buy another treat? Nope, because if I tried to put another treat in here, my answer would be $26. But I don't have $26. So I'm going to erase my line and I'm not going to add any more treats. So now I need to find out how much money she has left. So now I know she spent $23 total because she got the pupcake and 1, 2, 3, 4 treats in order to figure out that she had. So now we need to figure out how much money she'll have left after that. So I'm going to do 25 minus 23. 25 is how much money she has total. 23 is how much she spent. So I'm going to subtract that and have $2. Lastly, I'm going to write it in a sentence. And I'm going to say, Angelica, I'm going to look back at my problem, my question, and make sure my sentence is matching my sentence. The sentence says, how much money will she have left after she buys the pupcake and as many treats as possible? So I want to say, Angelica will have $2 left after buying the treats and pupcake. Okay, so now I check over my answer. Is the leftover money less than my estimation? Check. My leftover money is only $2, and I said it has to be at least less than 15. And also, I wrote it in a sentence to make sure I was answering the question. Number 24. Williams had a collection of 76 toy dinosaurs. He took out his favorite 12 dinosaurs. Then he equally divided the remaining animals between his 4 friends. How many stuffed animals did each of his friends receive? So I'm going to underline how many animals did each of his friends receive. Circle 76 toy dinosaurs. Circle 12 dinosaurs. I'm going to underline equally divided them. The remaining animals between his 4 friends. So my first question I'm going to ask myself is, what do I know about this problem? I know that my friend Williams had 76 dinosaurs. He wanted to keep some for himself, and then he wanted to divide the rest between his 4 friends. What am I trying to find out is how many, this should say dinosaurs, did each of his friends receive? So I'm first going to make an estimate. And he had 76 of them, and he kept 12 of them. So I'm going to do about 75 minus 10 would be about 65, and he gave them to his 4 friends. So I know that 4 times 10 is 40, which is pretty close to 60. So I know that the answer is going to be greater than 10 because I know that his friends are going to get more than 10 dinosaurs based on my estimation. So what I'm going to do next is start my plan by drawing my model. So I'm going to draw my model plan. I'm going to draw my handy dandy tape diagram again. This is the total amount of dinosaurs. So I'm going to write total equals blank. And I'm going to look back at my problem. We started out with 76 dinosaurs total. And then I know he takes them out. So I'm going to write a W for Williams, that he took out 12 dinosaurs to keep. And then I'm going to draw a line for each of his, or a section for each of his 4 friends. So friend 1, friend 2, friend 3, and friend 4. So he took out those 12, and then we want to know how many each of his friends have. So now I'm going to come over here and start solving it. I'm going to put question marks now here because we don't know how many each of his friends has yet. So when I solve the problem, the first thing I'm going to do is figure out how many dinosaurs he's going to give to his friends total. So he has 76 dinosaurs. He kept 12 for himself. I'm going to subtract those two. 6 minus 2 is 4. 7 minus 1 is 6. So 64 dinos are going to go to his friends. So now, if each of his friends get equal amounts, I could go through and start going 1, 2, 3, 4, 5, 6, 7, 8. I could give 1 to each of the friends in these boxes until I get all the way up to 64. But as we talked about in class, that's not a very efficient strategy. So it takes a long time. And also, students frequently mess up on that strategy because they miscount. So I'm going to show you a different strategy that you can use to be able to find out the answer. So since I'm dividing them up into 4 friends, I'm going to start with a 4 fact that I know that's going to get as close to 64 as I can. So my object is to get to up to 64 and have the friends have the same amount. So 4 times 11 is what I'm going to start with, because I know 4 times 11 is 44, and that's pretty close to 64. Now I'm going to keep up adding up 4 and multiplying by the next number until I get all the way up to 64. So 4 times 12 would be 48. 4 times 13 would be 4 more than 48, which is 52. 4 times 14 would be 4 more than 52, which is 56. 4 times 15, 56 plus 4 is 60. 4 times 16, 60 plus 4 is 64. Stop. I got my answer, 64. So 64 is not I got how many dinosaurs I wanted to get up to. So that means each of the 4 friends got 16 dinosaurs, because that would give us a total of 64 dinosaurs that he gave out to his friends. So now I'm going to write my sentence. I'm going to go back and read my question in order to write my sentence. How many dinosaurs did each friend receive? Each friend got 16 dinosaurs. I'm going to check. I said my estimate was my answer should be greater than 10 dinosaurs each, and each friend got 16 dinosaurs. So that checks for reasonability, and I know it answers my question because I went back and looked at the question and I wrote it in a sentence. Last section, balancing equations. Remember, these problems are about balancing and not about solving. Adding and multiplication, you should do opposite operations to balance. Subtraction, you should do the same operations to balance. Without adding the numbers on each side of the equation, which reasoning could explain why the equation must be true? So 86, I'm going to write this over here because I have a little more space. 86 plus 43 equals 82 plus 47. So I want to make these balanced. In order to make 86 equal to 82, I have to subtract 4. Then I want to make 43 equal to 47. I have to add 4. I have to do the opposite operation. So now they're balanced. I subtracted 4 from one and I added 4 to the other. So now I'm going to go through and see which one of these talks about adding 4 and subtracting 4. If it doesn't talk about adding and subtracting 4, the answer is wrong. A, both sides have a number 8 in the tens place added to a number 4 in the tens place. No, that's not talking about adding 4 and subtracting 4. You can subtract 4 from the left side to equal the right side. Nope, because that is only talking about subtraction, and we want adding and subtracting when we do addition problems. Both sides have a larger number added to a smaller number. Nope, I can easily prove that wrong. That is not true, and that's not what we're trying to get to. D, you can subtract 4, I hear that, and add 4 to the left side to equal the right side. Check, that's exactly what we did and what we were looking for. 26. Without subtracting the numbers on each side of the equation, which strategy could we use to figure out the unknown number that makes the equation true? 58 minus 29 equals 53 minus n. This is subtraction, so remember, subtraction is the same. So I'm going to write my numbers down here to be able to have a little bit more room. So whatever I do to this side, I have to do to this side because subtraction is the same. So I want to get 58 balanced to 53. To do so, I'm going to subtract it by, not 3, silly Miss Tupper, 5. 58 minus 5 gives me 53. If I subtracted from 5 here, I have to subtract from 5 here as well because subtraction is the same. 9 minus 5 is 24. So n must equal 24 because I did 29 minus 5 equals 24. So now that I know that it's balanced and n equals 24, I'm going to look for one of these that talks about 29 being subtracted from 5 gives us the answer of 24. If I don't see that, it is not the answer. A, subtract 5 from one number on the left side and add 5 to the other number on the left. The unknown number must be 29 plus 5. Nope. This is plus and I want minus. Not right. B, subtract 5 from both numbers on the left. The unknown must be 58 minus 5. Well, 58 minus 5 gave me 53, but I need to define n. So n was 29 minus 5. So that's not right either because this says 58. C, subtract 5 from both numbers. We did that. The unknown number must be 29 minus 5. Yay, that is the one we're talking about. I see 29 minus 5, and I see 29 minus 5 right there. Whoopsies. Sorry, you couldn't see the bottom part. But those match, so that one would be correct. We could check over D just in case. Subtract 5 from one number and add 5 to the other number. Nope, that's not what we did already. The unknown number must be 58 plus 5. Definitely not, because we did not do any adding in this problem. Last two on our review sheet. 10 times 6 equals 5 times 12. Without multiplying the numbers on each side of the equation, which reasoning could explain why the equation must be true? The equation must be true because, so it's one of these answers. Before I get all crazy about what these say, I'm going to use my balancing technique to see why these are balanced. Multiplication, we have to remember, is also opposite, just like adding. So whatever I do to this side, I have to do the opposite operation to this one. So 10, I'm trying to make it equal to 5. And I'm going to do that by dividing 2. If I divided 2 on this side, I have to multiply 2 on this one, which is 12. So now I have a balanced equation of 5 times 12 and 5 times 12. So now I'm going to look for one that talks about dividing by 2 and multiplying by 2. So A says you can multiply both of the numbers on the left side by the same number to equal the right side. Well, that can't be right because I just talked about dividing and multiplying. B, you could divide by 2 on the left side to equal the right side. Nope, I want dividing and multiplying, not just dividing. You could divide by 2 and multiply by 2 on the left side to equal the right side. Yes, that's exactly what I did. I divided by 2, I multiplied by 2, and I got the same as the right side. Let's just check over D just in case. You can subtract 5 and add 5 to the left side to equal the right side. Nope, because we're doing multiplication, we are not talking about addition and subtraction. We're talking about multiplying and dividing. Last one, number 28. 4 times 9 equals 12 times n. Without multiplying the numbers on each side of the equation, which reasoning could you use to figure out the unknown numbers that makes the equation true? A. Oops, sorry. I got ahead of myself. We're not going to read these over and get overwhelmed until after we balance our equation with the strategy I taught you. So 4 times 9 equals 12 times n. 4, we're trying to make it equal to 9. 4 times what will give me 12, and that's times 3. I'm going to do the opposite, so I'll have to divide this side by 3. 9 divided by 3 is 3. So n must equal 3 because 9 divided by 3 gives me 3. So I want to look for something in the problem that tells me 9 divided by 3 equals 3, and that tells me n is 3. A. One factor should be multiplied by 3, and the other divided by 3. The unknown number must be 4 divided by 3. Well, it was multiplied by 3 and divided by 3, but the unknown number was not 4 divided by 3. It was 9 divided by 3. B. Both factors on the left side should be multiplied by 3. I already see something wrong. We didn't multiply both of them by 3. We multiplied and divided. The unknown number must be 9 times 3. Nope. Both factors on the left side should be increased by 3. The unknown number must be 9 plus 3. Nope, we know we're not doing adding or subtracting in these. D. One factor on the left side should be multiplied by 3, and the other divided by 3. The unknown number must be 9 divided by 3. Ding, ding, ding. D is our right answer because we multiplied by 3, divided by 3, And our answer for n was 9 divided by 3, which gave us 3.